Okay, so today's lesson's on atomic structure. So it's basically the introduction to how atoms are structured and what they look like. So at the top of page 19, there's some revision questions. I'll get you to do them now. Um, the syllabus outcome. So we're investigating the basic structure of stable and unstable isotopes by examining their position in the periodic table, distribution of electrons, protons, and neutrons in the atom, representation of the symbol, atomic number, and mass number. Okay, which is we also call the nucleon number. I believe we also call it the standard atomic weight. So if you haven't done the revision questions, pause now, have a go at them. If you have done them, let's go through the answers. So firstly, elements are substances made up as a single type of atom. Okay, so remember, elements are just the one type of atom. As soon as we introduce second ones, they're compounds. So compounds are substances made up of two or more different elements chemically bonded. And lastly, mixtures are substances made up of from mixing two or more other substances together. It can be homogeneous or heterogeneous. Remember, homogeneous is the same consistency throughout the whole mixture. So milk, tea, that sort of thing. And heterogeneous was things that aren't the same. So, sand in water, muddy water, that sort of stuff. So let's start off with a little bit of revision again from year 10 and earlier. So atoms, they're composed of three different subatomic particles. Okay, so we did say that atoms are the smallest indivisible. Realistically, we do have other things within. So we have these protons, neutrons, and electrons. So the protons and neutrons are contained within the nucleus at the center of the atom, with the electrons orbiting around the edges. Okay, and so this is just a picture of a basic structure of the atom. Okay, so we can see our protons and neutrons in the nucleus and our electrons orbiting around. Okay, the scale's a bit off. The nucleus is actually about 1/10,000th the size of the electron orbits. Okay, so very tiny. But yeah, it's there. It's very dense, right at the center of our atom. Now, let's have a look at the individual subatomic particles. So firstly, let's have a look at protons. So protons have a positive electrical charge. Okay. Um, they also have what we call an atomic mass of 1. So basically, when we're dealing with the standard atomic weights or the atomic mass, we say that neutrons have a value of 1. Sorry, protons have a value of 1. Neutrons also have a value of 1, so they're about the same mass as a proton, but the main difference is that they don't have an electrical charge. Okay, so they're completely neutral. Um, Lastly, we have the electrons. They have a negative electrical charge, which is the same charge as a proton, but the opposite. Okay, whereas a proton has +1, an electron would have a -1 charge. Now we say that electrons have an atomic mass of 0. It's not quite correct. They do have mass, but it's only about 1,000th the mass of a proton or a neutron. Okay, so we kind of ignore it a little bit when we're dealing with mass on a big scale, but it does actually affect it once we get down to fourth, fifth, third or fourth decimal point of the atomic mass. So it is important, just not at this level. Now let's just have another little bit of revision. What are the 4 pieces of information given to us on the periodic table for most of the elements? Okay, so every element has 3 bits of information. There's that third one's on most of them. So the number at the top, that's our atomic number. We also have the symbol, okay, used for writing in reaction equations. We have our atomic mass or standard atomic weight, and we have the name at the bottom. So remember that standard atomic weight's not going to be there for every atom, but it'll be there for most of them. So remembering that, let's move on. Now, the atomic number, that represents the number of protons within that atom. Okay, basically, if you change the number of protons, you change the element. Okay, so whatever that number is, that's the number of protons. So carbon has a 6 at the top. Every carbon atom has 6 protons. If you change that number, for example, if you change it to 7, it's no longer oxygen, it becomes nitrogen. Okay. Or if you take one out, if you take one, it goes from 6 to 5. 5 is no longer carbon, that's boron. Okay, so it completely changes the actual element. Now, the atomic mass number, that represents the combined number of protons and neutrons within the atom. Okay, so for example, carbon has a mass number of 12. That means that it's got 6 protons because you can't change the number of protons because it's got 6 for the atomic number. So it's 6 protons, 6 neutrons adds to 12. Now, this information is usually expressed with the atomic mass at the top left of the atomic symbol and the atomic number to the bottom left. So we've got an example here again. We've got some, we have some examples here. With carbon, we've got the atomic number of 6, the atomic mass of 12. Helium, atomic number 2, atomic mass 4. And sodium with an atomic number of 11 and a mass number of 23. Now, let's break it down, go through what they actually mean. So we are 12,6C. So remember, 6 is the atomic number. It tells us that carbon has 6 protons. If we look at the mass number at the top, it tells us that carbon has a total of 12 protons plus neutrons. Okay. Now, because just using basic maths, carbon then has 6 neutrons. So we do the top number, take away the bottom number, it gives us the number of neutrons. And the number of electrons in a neutral element, so there's no charge on this element, so the number of electrons will equal the number of protons because the positives and the negatives balance each other out. Okay, so carbon has 6 electrons. Let's have a look at helium. Okay, starting with the number at the bottom, it's our atomic number. So atomic number, sorry, for helium, the atomic number is 2, so it means we have 2 protons. Having a look at the mass number, it's 4. So again, it has a total of 4 protons plus neutrons. Taking away the number of protons from that gives us 2 neutrons. Okay, so kind of, so that one's pretty easy. Now let's have a look. Oh, sorry, yeah, the number of electrons. Again, this is a neutral atom, so the number of protons equals the number of electrons. So this helium atom has 2 electrons. Let's have a look at sodium. So we have a atomic number at the bottom of 11. Tells us that sodium has 11 protons. Looking at the atomic mass, the sodium has a total of 23 protons plus neutrons. So if we take 11 from 23, it leaves us with 12 neutrons. And again, there's no charge on this one, so the number of protons equals the number of electrons, which is 11. Okay. So I'll get you guys to have a go at this. So I've given you 3 examples here. So we've got lithium, aluminium, bromine. So using that process that I just went through, have a go at determining the number of protons, neutrons, and electrons for each of these atoms. Okay. So just pause the video and we'll come back in a sec. Okay, so hopefully you've had a go at that. Let's go through the answers. So 7,3 lithium. We've got the atomic number of 3, mass number of 7. So that gives us 3 protons for lithium, 4 neutrons, and 3 electrons. 1327 aluminium, 13 protons because that's the atomic number. 27 take away 13 gives us 14 neutrons. And again, these are all neutral, so it gives us the same number of electrons as there are protons. Lastly, bromine, atomic number of 35, so it's 35 protons, 35 electrons, and 79 take away 35, so 44 neutrons. Okay. So we'll also be looking at isotopes today. Isotopes are two or more forms of the same element that have the same number of protons but a different number of neutrons. Okay, so I'm going to show you an example of hydrogen. Hydrogen has three isotopes. So it has this first one, which is 1,1 hydrogen. So it has one proton, zero neutrons. Okay. We also have the second one. We call this deuterium. It has one proton and one neutron. Hydrogen can also exist as this third isotope, which we call tritium, which is one proton and two neutrons. Okay, so chemically, if we're doing reactions with any of these isotopes, they all act like hydrogen because they are hydrogen. They've just got those extra bits of, those extra neutrons that add that extra bit of mass. Okay, so they weigh different amounts, but they react chemically the same. And so, yeah, have a go at determining the number of protons, neutrons, and electrons in these three different oxygen atoms. So again, we just use the same process, but this is just to show you how the neutrons differ across different isotopes. Okay, so have a go at that and pause the video, and then we'll come back to it in a sec. Alright, so hopefully you've had a go at that. Let's have a look at the answers. So all of the oxygen atoms have an atomic number of 8. So they've all got 8 protons, they're all neutral, they've all got 8 electrons. But if we look at the one at the top, the 16 oxygen, we've got 16 take away 8, so 8 neutrons. 17, 8 oxygen, 17 take away 8 is 9 neutrons, and 18, 8 oxygen is 10 neutrons. Okay, so you can see that with those three different isotopes of oxygen, we have different different numbers of neutrons between them. Okay, and so that applies across all atoms. There could be different number of isotopes for every single one. Alright, so that's isotopes. Let's move on to ions. Okay, so hopefully you know a bit about ions, but if not, we're going to go through it now. So an ion is an element that has gained or lost an electron or electrons. So it can lose one or gain one or multiple. If an element loses an electron, it becomes positively charged. So remember, electrons are negatively charged. So if you lose one, the atom becomes positively charged. If an element gains an electron, it becomes negatively charged. So again, electrons are negatively charged. If we have one more than normal, then the atom as an overall has a negative charge. So the charge that's on an element is shown at the top right of the atomic symbol. So you can see here we've got Na plus and Cl minus. Okay, on the sodium, that plus that we've written there indicates that sodium has lost an electron. Okay, so it's become positive, so we've lost that negative charge. The chlorine, on the other hand, that's gained an electron, so it's got an overall negative charge. So it means there's an extra electron in there somewhere. Now, elements that have lost or gained more than one electron, we put a number in front of the charge. So here we've got magnesium 2 plus and arsenic 3 minus. Now, the 2 plus basically means that this magnesium has lost 2 electrons. Okay, so we've lost 2 of those negative charges, so it becomes positively 2 charge. Now, arsenic, it's got a 3 minus, so it means it's gained 3 electrons. Okay, so 3 extra negative charges gives it that 3 minus charge. So what we can do is we can use this information to then figure out the number of protons, neutrons, and electrons within an ion. So here we've got oxygen. Now I've got this one already written for you in your book, so you just pay attention for this one. So firstly, the atomic number tells us that oxygen has 8 protons. We then go to the mass number. So it tells us that oxygen has a total of 16 protons and neutrons. So we do 16 minus 8, which gives us 8 neutrons. So that's what we've been doing so far, so that's pretty easy. We then have to take into account this 2 minus. So neutral oxygen, if that charge wasn't there, neutral oxygen would have 8 electrons. But we now have a 2 minus charge, which means it's gained 2. So it now has 10 electrons. Okay, so O2 minus has 10 electrons, basically. Now, let's have a go at potassium. Potassium likes to exist as a +1 charge. So starting off with the atomic number, tells us that potassium has 19 protons. Taking into account the mass number, it tells us that there's 40 protons plus neutrons. And so we do 40 take away 19, which gives us 21 neutrons. Now, let's have a look at the electrons. Again, for a neutral element, the number of protons equals the number of electrons, sorry. So normally potassium would have 19 electrons, but it's now got a +1 charge, which means it's lost 1. And so that goes from 19 down to 18 electrons because it's lost that one. Okay. So using that method, have a go at these. So here's 3 different ions. We have phosphorus 3 minus, calcium 2 plus, and vanadium 5 plus. So just using the information provided there, determine the number of protons, neutrons, and electrons. Pause the video, have a go at that, and then we'll come back in a sec. Alright, so here are the answers for this one. So phosphorus, we've got 15 protons because of the atomic number. Neutrons is 31, take away 15, so it gives us 16 neutrons. Now, neutral phosphorus would have 15 electrons, but it's got 3 extra because of that 3 minus charge. So it gives us 18 electrons. So it's got more than it would normally have. Going down to calcium, so it's got an atomic number of 20, so 20 protons. Mass number of 40, so 40 minus 20 gives us 20 neutrons. Now it's got a 2 plus charge. So remember, 2 plus means it's lost 2 electrons. So it would normally have 20, but take away 2 gives us 18 electrons. Now vanadium 5 plus, it's got an atomic number of 23, so 23 protons. It's got 51 take away 23, so 28 neutrons. And it's got a 5 plus charge, which means it's actually lost 5 electrons. So if we do 23 take away 5, that gives us 18 electrons. Now you'll notice a little pattern here. All of them have 18 electrons. I'll let you stew on the reason for that, and I'll ask you in another lesson. See if you can figure it out. Now, summary for today's lesson. Atoms contain protons, neutrons, and electrons. The atomic number is equal to the number of protons. The atomic mass is equal to the number of protons plus neutrons. Neutral elements have the same number of protons and electrons. Isotopes are the same element with different number of neutrons. And lastly, an ion is an element that has gained or lost an electron. And remember, the important thing that I see a lot of people get stuck on, if it gains an electron, it becomes a negative charge. If it loses an electron, it becomes a positive charge because the electrons are negatively charged themselves. So if we lose a negative charge, it becomes positive. If we gain a negative, it becomes negative. Okay, so once you've got all that down, go to the bottom of page 23. There's a few pages of questions. So have a go at those as best you can. And yeah, that's all for today.